So, are we going? We're going. Alright. So, John Todd, do me a favor. Can you make that light turn on there? Take a little walk. So, MAVA equals MBVB. Molarity of acid, volume of acid. Molarity base, volume of base. If you look at number 1, NaOH is the base. Thanks, John. HCl is the acid. So if you read through the question, it says calculate the molarity of 50.0 milliliters of NaOH. So that is this. We don't know that. It says calculate the molarity of the NaOH. That's the molarity of the base. That's what we're solving for. The 50.0 milliliters goes in for VB. So VB is 50.0. And I'm keeping all the numbers, 50.0, because sig fig rules come into play. That has been neutralized by 25.0 milliliters of a 0.20 molar solution of HCl. So that 25.0 and the 0.20, that belong to the HCl. That's the acid. So this number here is 0.20. That number here is 25.0. So when I'm reading the question, I am either making a mental note or writing it down as I read it, what numbers go in which spot. Okay? In other words, which numbers belong to the base, which numbers belong to the acid. Okay? So now what do? Well, we solve for the question mark. So it's 0.20 times 25.0 equals x, for the question mark I use x, times 50.0. Once you get that set up, it's easy, right? You just multiply, then divide. I'm skipping the math part because, again, I think that's easy. And I get whatever I said, 0.10 capital M for number 1. Why 2 sig figs? Who could help us out with that? Why 2 sig figs? This has 2. 2 sig figs. Why does the answer have 2, not 1, not 3, not 4? Why does it have 2 sig figs? Who remembers the rule when multiplying and dividing? Zach, remember the rule?
I was just going to say the other molarity has 0.20.
Well, sort of, yeah, sort of. The rule is when you multiply and divide, you round the number so it has the lowest number of sig figs. What does that mean? How many sig figs does this number have right here? 2. Skip that 0. Okay, you can't start counting with 0. Decimal point present. Here's the Pacific side. So you count going this way. 1, 2. This has 2 sig figs. This has 1, 2, 3. That's whatever. 1, 2, 3. So 2 is the lowest number. That's why my answer is 0.10. If 3 had been the lowest sig fig number, I would have to add a 0. 0.100. That would have had 3. So that's good review for you guys, because you will have to do it on the Regents. At least one question, for sure. It'll ask you to round your answer, or they'll give you a number, or they'll give you a question, and they'll say how many sig figs should it be rounded to. Something to that effect. Okay. Questions on number 1. Okay. Number 2. So I'm just going to leave that the same. And question number 2. This time it's asking for moles of KOH. So we have to find the molarity first, then use the molarity formula to get moles. So this one's kind of a two-step problem. So here we go. How many moles of KOH solution are required to exactly neutralize 0.50 liters of a 1.5 molar HCl solution? Volume of KOH is 0.25. All right. So the volume of the base, KOH, right here, is 0.25 liters. It says the HCl is 1.5. That's going to be my molarity of the HCl. The volume of HCl, 0.50. And again, my X or question mark is going to be the molarity of the base, because we don't know that. We don't know that. So now we set it up. 1.5 times 0.50 equals X times 0.25. Maybe I'll get out a new marker. This one's not so good. But multiply, divide. X equals, I think 3 is the answer. So 3.0 is our answer to X. That's molarity. That's not the answer to the question. That's molarity. The question wants to know how many moles. How many moles of the base. That's molarity. Molarity formula is moles over liters. It's on the back of the reference table. So we take 3, plug it in for M. X goes on top. We're looking for moles. The volume of the base is right here. 0.25. So 3 times 0.25, right? Cross multiply. X equals 0.75 moles. And because that's 2 sig figs and that's 2 sig figs, your answer has 2. 0.75 moles. That's the answer to number 2. Questions? You need to ask me questions. Besides lab, we're basically done with this today. I'm going to give you those worksheets for homework. We'll go over those, but this will be the last time I go slow. No questions. All right. Let me see if this one. I'll try it. I think this one dies quickly. All right. So that's number 2. All right. So number 3, I'm going to allow one of you to get involved here. First of all, when it says it turns light pink for 30 seconds, then disappears, this is what it's saying, okay? It means it's neutralized. It means it reached the end point. It means the titration's over and your pH is going to be about a 7. That's what that means. That's why they tell you that, okay? That also means your H plus and OH minus are about the same level. That's what that means, neutral, pH 7. So, who can set up number 3 for me? How about Abby? I haven't talked to Abby yet today. Alright, well then, I'm going to help you walk through it. Let's look at the first 2 numbers in number 3. It says a 1.00 m solution of NaOH. What does that mean? Which variable is that? MA, VA, MB, or VB? The 1.00 molar solution of NaOH. It's an M, but it's not MA. Why is it not MA? It's MB. Why is it MB? Well, what's NaOH? A base or an acid? It's a base, but how do you know that? Besides the fact that I said it was. Table L, good. So if you guys ever get confused, you don't know the formula and you don't know if it's an acid or base, look it up on table K or L. So it's not, did you say L? I feel like I said K. Table L. NaOH is on table L. Very good. So 1.00 goes here. 1.00 goes in for MB. Alright, now it says, is used to titrate 20.00 milliliters of an unknown concentration of an HNO3 solution. It's kind of wordy, kind of confusing, but that 20.00 milliliters belongs to the HNO3 solution. So Abby, where's that number go? MA, VA, or VB? VA, very good. So VA is 20.00. Good, so we're getting there. It says phenolphthaleins used, blah, blah, blah. Okay, now after 35.00 milliliters of NaOH has been added, the solution turns light pink for 30 seconds, disappears. Calculate the molarity of HNO3. All right, so that 35.00 milliliters of NaOH, Abby, where's that go? VB, good. So VB is 35.00. Our X goes in for MA because the last sentence says calculate the molarity of the acid, right? HNO3. So now it's X times 20.00 equals 1.00 times 35.00. Marker's not much better. So 35 divided by 20, X equals 1.75 M. That's the answer to number 3. So if you were having trouble, the reason I went through it slow with Abby that way is because that's how I want you to do it. Read it and go number by number, plug it in the equation. Just make sure you know which one's the acid, which one's the base. Questions on 3. Taking a lot of time to go over this. I hope you guys are benefiting from it. I hope you understand what's going on because you're not asking me any questions. Okay. Alright, and the last one. The other side's a little bit easier as far as there's no calculations. Number 4. 250.0 milliliters of a 3.5 molar HBr solution. So both numbers belong to HBr. Michaela, is HBr an acid or a base? Acid. So 3.5 goes here, and 250.0 goes there for VA. Now it says, is used to completely neutralize 200 milliliters of an unknown concentration of CaOH2. That's the base. That's here. 200.0, X goes for MB. Calculates the molarity of the base. So 3 point. Let me go back to the blue here for a minute. 3.5 times 250.0 equals x times 200.0. X equals, multiply and divide, whatever I said, 4.4. And I abandoned my sig fig rules on number 3, but there was 3 sig figs. Here it's only 2 again. Here's 2, this has 4, that has 4, so that can only have 2 because of that. So 4.4 is what we rounded to. 4.4 for number 4. Questions? Comments? Concerns? It's a problem with these giant, wide mouth bottles. Or maybe I have a hole in my lip. Moving on. 5. Alright, so using the final solution of number 3. So number 3 explained that the solution was neutralized. It said that. It said it turned light pink for 30 seconds. So if you see that, light pink, that means it's neutral. pH of 7. So the answer to 5B is 7. It's supposed to be 7. If you neutralize an acid with a base, neutral means 7. So what about 5A though? Morning.
Morning.
Catherine, what do you think for 5A? If it's neutral, what does that mean? Say it again. Well, you said. I heard you say something. I wasn't sure which one it was. Is it equal to, less than, or greater than the H plus and the OH minus? Equal. Very good. If it's neutral, you'll have the same amount of H plus and OH minus. So the answer is they're equal. H plus is equal to the OH minus concentration. That should make sense to you guys. Remember the bars we drew in our notes. We want them to be the same level when they're neutral. All right. C. Justin, what do you think? Blue, try again. Look at table M. Yeah, it's yellow because 7 is below, what is it, 8 is the... Yeah. So, thymol, maybe you looked at brown thymol blue? Yeah. Thymol blue, a little different. It would be yellow with a pH of 7 because it's below that range. Below that range. Questions on 5? Okay, now... 6. A lot of you did this, and a lot of you were kind of detailed. I can see some weren't so detailed. So let me just go through it again. Why do I do this? Because I've seen questions on the Regents where they give you a picture of the setup with the burette and the flask, and then they don't really tell you much more. They give you some information about how much of each one, base and acid, but you're expected to kind of understand where the base is, where the acid is, and how it works. So I just wanted you to kind of practice drawing something that looked like a burette. I can't draw a burette. But up here, this is the burette. That's where the base is. Okay. Down here, you're going to have some sort of flask. Hopefully better looking than my flask. In there, that's going to be your acid. Okay. That's the unknown. That's the unknown concentration of the acid. This is the base, and I think the base has a molarity of 1. So that would be your 1 molar NaOH. In the flask would be the unknown HCl. The indicator would go in here. You got to put the indicator in here. Otherwise, as you drip base, and the fact in lab, almost every year, there's a group that does it. They forget to put the indicator, and they literally go through the entire thing of base. It never turns color, and they're like, what's going on? How come ours isn't turning color? You got to put the indicator in. Okay? I had a kid one time, I guess I was really busy, or there was a lot of kids that needed help or something. One group literally had this flask like overflowing because they didn't put the indicator in and they kept adding base to it, and I guess I didn't catch it. You're only supposed to have like a little bit of liquid, not much. So, and then they did put a drop after I came over to help. Guess what color it turned? Super dark pink, right, because they had like 90% of it base. So you got to make sure the indicator's in there. That's really the most important part. What else are we supposed to label? Where the HCl is, we did that. Indicator. Name the glassware. This thing's called a burette. What's that called? What's this called? I say flask, but what's the real name? Erlenmeyer flask. Good. So burette, Erlenmeyer flask. Drip the base into it. And what's the end point and what's the significance here? Define the term end point and how it applies to titration. Kai, what's end point?
It's when it's neutral, or when it becomes neutral.
Yeah, in this one it is, yes. if you take AP Chem in a couple years, you'll see that it's not always neutral, actually. But anyways, that's irrelevant right now. So be more literal. What do you see happen at the end point?
When the color changes.
Yeah, that's what the Regis is going to want you to say, is when the indicator turns color and stays changed for a little bit, 30 seconds or more, that's your end point. And you are right, Kai. In most of the titrations, that means it's neutral. Most of them. But not always, because you could do a titration with methyl orange. Methyl orange pH range is 3.1 to 4. What is it? Someone look it up. 4.4. So you could use methyl orange in a titration. But when it became, when the end point occurred, it's going to be in here, between 3 and 4. So it won't be neutral. So that's why what Kai said is right for this question, but I want to make you guys understand, or help you understand, you can use other indicators, it just won't be a pH of 7 when you're done. It'll be whatever that range is. So if you wanted to do an indicator, a pH, a titration to get a pH of like, I don't know, I guess 4 would be methyl orange. That'd be a good one. Okay? That'd be a good one if you want your end solution to be in that range. Use that indicator. Don't use phenolphthalein, it won't change color. Hopefully that makes some sense. But yeah, end point is when it turns color. You'll see that in lab. Alright, so I thought that was a pretty good worksheet to help you practice what we did yesterday. We still got a little time. I am going to start the next unit. Questions for me. So I would say, before I kind of move on, these titration problems are important to know how to do, but I would say more importantly, can you identify acids and bases? Do you understand how they dissociate in water? Do you understand how to read table M? Those are more important, I would think, than titration in general. I've been teaching a while. I think those concepts are more important than just doing the math for titration. All right? So hopefully that's making some sense to you. And we'll do more with that in lab. So we're going to move on. Let me give you these two worksheets. It looks like a lot of work, but it really is not that much. I'm going to give you this one first. 74, 75, 76. Right on top, this weird picture you've never seen before. You don't know how to do that, so you're not going to do those for you. Okay? Alright, when I give this to you, keep it out. I'm going to tell you which ones not to do, because we haven't learned it yet. There's 2 more on the back. It's the new stuff. We're going to start in a couple minutes. So, you don't have to do all of this, and I'll give you the other one too. Anybody going anywhere over the long weekend? Doing anything fun? Going fishing with Brad?
Yep.
Up in, what is it, Black Lake? Don't fall in.
I'll make it forward. Titanic.
No one else? Kai, what did you say? You're going tanning? Is that what you said?
No, I said Titanic.
Oh, I thought you said I'm tanning. That's cool.
Okay.
So, I mean, I guess, as long as you're not going to a tanning bed, but, right here, 74, 75, 76. Don't do those. Don't, scribble out the whole thing, though, because I will be doing those with you in class next week, or homework next week, because that's the new stuff, okay? Flip it. Don't do number 54, 55. You don't have to do those. So, the ones that are starred on both sides, those are the acid-base questions. But I do want you to also do 51, 52, 53 up here with the H2O breaking apart, just for review. It's good review for you, okay? I have not put together a review packet yet. But fear not, I will. Okay, next worksheet. Tell you what, after June 15th, you don't have to come to school anymore. So, it's worth doing all the work now.
Actually, we do have Joey back.
Summer's almost here. Just a little more work. One more push. You guys will be good to go. Alright, this weird looking thing up here. Okay, that thing you're going to learn about next week. So don't do those questions. 71, 72, 73. Skip those. Okay, skip those. Everything else on that sheet, do. So I'm going to put the text out, okay, in the middle of the weekend at some point, reminding you. I'm probably not going to go through and say, don't do these and do these. I'm not going to do that. I'm just going to say, don't forget those 2 worksheets, since I just told you. All right? So that's that. It really isn't that much work. So.
Wait, so we're just running around the rest of the work?
Oh no, we're not doing them now. I'm going to start the new unit. So just for homework. All right. So yeah, I got a little bit of time. So we're going to intro electrochem. We'll get a new marker out. It's going to be exciting. It's going to be electric.
Yeah.
Electrochem. It's electric. Okay. Do you guys know the song? What's that stupid song they play at dances? It's old.
No.
Yeah. What is it?
I know what you're talking about. I know what you're talking about.
What's the name of that song? And people do like it used to be. It's like it's an old song. Maybe when you're like in middle school or whatever, kids like it. And they
Electric
kids
slide.
Yes.
Yeah.
I remember vividly when I was in middle school.
You were doing that?
Some girl. I mean, I probably did, but I wasn't doing it at the time. But some girl like totally messed up her knee doing that. Like an ambulance came and yeah, kids were laughing. And I was like, why are you guys laughing? I felt bad for her because she was like laying there. And the teachers didn't really know what to do, which I remember was weird. I remember the teachers being like, It was really a weird feeling. You expect teachers to know what to do, right? So I always remember that. And whenever I teach this, I always think of that girl. I don't remember her name or anything, but hope her knee's okay by now. It's been a long time. It probably is.
Right? Tell that to your kids though, like, oh yeah,
Well,
my knee's messed up, so dancing in middle school.
well, I'm sure it healed, but
But still.
I'm sure people get dance injuries all the time.
But you're in middle
You're like
school.
gyrating and moving around. I don't know.
Yeah, if you're 8, 9 years
If you're old, yeah, I guess. I don't know. All right, so electrochemistry. Here's the deal. The most important thing to understand about electrochemistry is it deals with transfer of electrons. Transfer of, I can spell. Transfer of electrons. And there's two types of processes in electrochemistry. So there's 2 processes. And the first one is using electricity to perform a chemical reaction. You guys ever hear the term electrolysis?
Yeah.
Where have you heard that, or why have you heard that? What's that?
Yeah.
Talked about in biology? Yeah, well, you can separate water using electrolysis. Technically, electrolysis, I'll put that under here. Electrolysis is using electricity to separate decomposed compounds like water. If you run electricity through water, you can separate it into hydrogen and oxygen gas. That's called electrolysis. Some people, I guess usually girls hear this or know about it more than guys, but you can get like body hair removed with electrolysis. I mean, guys know about it too, but it's just more common, I think, with females, like on their face and stuff like that. But that's the chemical change. I hear commercials for electrolysis, and they'll say, "Oh, it's permanent. You do it one time, the hair never grows back." That's because it's chemically altering the root. It's like destroying the root, so it won't grow back. So I use the analogy because it's a chemical reaction. So using electricity to perform a chemical reaction. The other type is the opposite. Using a chemical reaction, and everybody here knows this, using a chemical reaction to produce electricity. That's the other electrochemistry concept. That's the only 2 things we talk about. Is using electricity to perform a reaction, or using a chemical reaction to produce electricity. Everybody here, even little kids, understand that. So if you're sitting here going, I don't know what he's talking about, it's just because it's not coming to you. What's one thing we use in this world that uses chemicals to make electricity? Batteries. Okay? Batteries have chemicals in them that when they react, they produce electricity. And it all is because of that. Without electrons being transferred, you won't have electricity. Alright? So that's kind of the overview of what electrochemistry is and what we're going to be talking about. Now we're going to get into some specifics. I got a few more minutes left, so it's good. I feel good we can at least introduce this, then we get back kind of hit the ground running on Tuesday. All right, so redox reactions. What the heck is a redox reaction? All right, I'm going to teach you an acronym here. And the acronym is Leo GER. It's supposed to be a G. Leo the lion goes GER. I think that's what the book says. Or Leo the lion says GER. Leo GER is an acronym. L stands for lose, E stands for electrons, and O stands for oxidize. G stands for gains, E stands for electrons, R stands for reduce. So a redox reaction is when elements, compounds, are either oxidized or reduced. You've heard those terms before. So it's important to start right now to memorize this and memorize what it stands for. So Leo stands for lose electrons, oxidize. I'll explain what that means in a minute. GER stands for gains electrons, reduced. Lose electrons, oxidize, gain electrons, reduce. And redox stands for reduction oxidation. That's what redox stands for, reduction oxidation. So, I'm going to give you a simple example and we'll probably end on this. If we take iron, Fe solid, react it with oxygen gas, and we make rust, Fe2O3 solid. Actually, no, let me make that simple. Hold on. I'll use the other one. Trying to think. We'll just use FeO. And that's going to be 2 there and 2 there. So we have iron oxide. So if we take iron and react it with oxygen to get rust, get FeO. So I'll end with this. What's the oxidation number on these two? Who remembers what oxygen always is? -2. So what does that mean Fe has to be?
Plus one individual.
2. There's only one Fe. There's only one Fe. There's 2 FeOs, right? There's only one Fe. Only one Fe, one O, it has to be +2 -2. Stay with me. Over here, there's zeros. Elements in their pure state have no charge. Elements in their pure state have no charge. Now, last thing. Hopefully I can get it in. If not, we'll do it Tuesday. Fe is losing electrons, becoming positive. Oxygen's gaining electrons, becoming negative. So we would say Fe is being oxidized, oxygen's being reduced. And I'm going to stop because you're probably confused. So I'll pick that up on Tuesday. But that is electrochem. All right, good work. Have a good weekend. Tuesday we got a lot to do, so get ready.